Hey, Avi Loeb, how are you?
I'm doing very well, thank you.
Excellent, excellent. So glad you could join us for this live Q&A. We just finished watching your talk. It's super fascinating, super fascinating. It looks like we have a few people who have joined us here already.
Okay.
So the way these Q&A sessions work, you're most welcome to join us by kind of raising your digital hand. There should be a button on the lower side of your screen there. Or you can type questions directly into the chat here that Avi and I can see, and we can answer them from there. So why don't you start a little bit, Avi? When you were first asked to participate in the Warp Space Summit, obviously this topic is super fascinating, and there's got to be so much more to it than you're able to pare down into a 20-minute talk. Do you have any other thoughts that you can add about Oumuamua, if I said that correctly?
Yeah, you said it correctly. I mean, it was the first object that came from interstellar space into the solar system that we discovered in 2017, but we want to find more. And we want to find them when they approach the Earth so that we can send a spacecraft equipped with a camera that will take a close-up photograph. And that's part of the Galileo project that I announced in July. And we now have 25 scientists, exceptional astronomers engaged in this project, altogether 70 people. The second part has to do with objects that were claimed to be unidentified aerial phenomena, and they appeared in the Pentagon report to Congress on the 25th of June. And we are building telescope systems that would be able to take a high-resolution photograph of those. So altogether, we are searching for equipment that could have arrived near Earth from another civilization. So we are doing an experimental search, and even though I'm a theorist, I believe in the superiority of data and not prejudice.
Excellent, excellent. Well, we need an icebreaker here. It looks like we've got about 8 folks joining us. I know there's a few other sessions going on, but we've got the next 15 to 20 minutes. We might see some people join us and leave, kind of hopping in, hopping out. So I have kind of a question. I don't know if you have really an answer to this, but I've always been super fascinated with the idea of intelligent life out there. And you make one point in your talk about how they could have reached, our level of intelligence many years ago, like billions of years ago, in relation to the age of our sun and other suns. One thing I always wondered is could they see us kind of how we see like an insect, like so far behind in the intelligence scale that maybe we're just not that interesting to them because they're so advanced?
Definitely. I think that's the most likely case. One thing I should clarify, that most stars indeed formed before the sun, billions of years, and the star that hosted those civilizations that predated us may not be around anymore. So those civilizations might perish, but it's sufficient to have one advanced technological civilization that went beyond where we are right now. We are developing artificial intelligence systems, and we will likely send them into space soon. And if a civilization like ours did that already, then all the habitable planets within the Milky Way galaxy could have objects, probes near them, because it's sufficient to have one AI system that has 3D printing capabilities, and it can replicate itself. And over 1 billion years, you can pretty much fill up the entire Milky Way galaxy. And the fundamental question is, do we live in that reality or not? And the way to find out is by looking through telescopes. And you are correct that if there are any living cultures out there that are thousands of years, maybe millions of years more advanced than we are, because we are just in the first century of our technological development, we might look like ants on the sidewalk of the Milky Way for them. We are not that special. And that could be one explanation for the Fermi paradox, that indeed we expect them to come to our backyard and celebrate, but they don't care so much about us. And of course, we need to find about them, because that would educate us about what we might become in the future, and perhaps we will aspire to behave better than we do right now.
Right. Okay. We have lots of listeners. Here we go. Douglas, at what point do you think humans will become interesting enough for aliens to approach or try to interact with us?
Yeah, if you look at human history, one thing you find is that groups of people tend to try and feel superior relative to others. And that's the biggest mistake throughout human history. I was asked once, what is the way I define an intelligent culture? And I said, following the guiding principles of science, basically cooperation and sharing of evidence-based knowledge. And the first facet of that is cooperation. We don't cooperate much in between nations, between people, and we don't rely on evidence. That's the other thing. So that's why we are not that intelligent as of yet. But the best example for non-cooperation and for trying to feel superior relative to each other is the Second World War, where the Nazi regime triggered the death of 75 million people. That was 3% of the world population in 1940. It's 20 times more than the number of deaths caused by COVID-19 so far. So just think about it, a group of people trying to feel superior relative to others killed 20 times more than the virus so far. And so that illustrates the fact that, if we find a civilization far more advanced than we are, all the genetic differences between us would look minuscule. They would be laughable. And the Nazi doctrine would make really no sense whatsoever. And I hope that by seeing others that are far more advanced than we are, we will be convinced, we will be inspired to treat each other with respect and feel as members of the human species. And we share the same fate here on Earth. So we should plan together how to make our life in the future better.
Absolutely. Absolutely. Good question. Good question. Any others? Oh, man, we're up to 16 people here now. Someone must have a question. Oh, do you think it's possible that Earth already has been visited?
Yeah, one thing to keep in mind is that the recorded history here on Earth is at most 10,000 years old. So that's a tiny fraction. It's 1/1,000,000th of the age of the solar system. And so when we say we don't have any record that proves beyond any doubt that we were visited, although, some people suspect maybe there were some incidents that are not really clear. The point is that if they visited us 1,000,000 years ago, we would not have a photo album of that. Nobody recorded back then. There were no humans millions of years ago. So again, Fermi's paradox saying, where is everybody? Well, they may have been here a few million years ago. We just weren't around at the time. It's just like saying, nobody knocks on my door at home, therefore I have no neighbors. Well, you have to wait until you hear something. And the characteristic timescale in astronomy is billions of years. That the age of the universe is 13.8 billion years. So when we talk about 10,000 years, that's nothing. So when we say were we visited or not, we can't tell what happened more than 10,000 years ago. We don't know. So it's possible. And since interstellar travel takes so long, that time scale is completely meaningless. And I should say that Oumuamua, for example, it took it 10,000 years to just traverse the solar system. So the object we saw in 2017 started its journey at the edge of the solar system 10,000 years ago when we started recording our history. So this is just to give you an example. And the solar system is tiny relative to the distances across the Milky Way galaxy. So the bottom line is we need to search for evidence. And I should say one example for a search is the moon. The moon is like a museum. It has no atmosphere. So unlike the Earth, when a rock enters the atmosphere of the Earth, it burns up. That's a meteor. And if it's less than the size of a person, you don't have any relic left. Moreover, the Earth has geological activity that mixes the surface layers with the interior every 100 million years. But the moon has no geological activity. The surface layer stays the same for a billion years. Billions of years, it has been the same. And also there is no atmosphere. So any equipment that lands on the surface of the moon that crashes with the moon is still there. So you can think of the moon as a museum. And we could search just like an archaeological site. We could search it in the future. The same is true for Mars. And then other than that, we can use telescopes to see if there is any equipment floating in space. Oumuamua was unlike a comet or an asteroid. That's why I suggested maybe it's artificial. And we should continue the search. And the same is true near Earth. So the answer is, in short, we don't know for sure, but we should search.
Absolutely. Absolutely. So Jacob's joined us live. It looks like you are muted right now. If you had a question you wanted to ask, I'll give you a second to unmute yourself. There he is. Hello.
Hello.
Hi.
Hi, Avi. Thank you for your great talk earlier. And my question for you is, there's something called antimatter in space, which is invisible to the human eye. So for a lot of time, we didn't know that it even existed, but now we do. And a lot of physicists are doing more research around it. Do you think that there's any possibility that antimatter could affect the movement of Oumuamua?
Yeah, so antimatter existed in the very early universe, when the universe was very hot. Equal numbers of particles and antiparticles existed early on. But eventually, only one in a billion matter particles survived, the electrons and protons, and the rest were annihilated with the antimatter. So we think, I mean, based on the standard model of cosmology, that there is not much antimatter left around, except, it could be produced in some very energetic events. For example, very energetic explosions or near a black hole, but it's very small quantities of antimatter. Now, for example, on Earth, in order to produce, for example, positrons, we need to invest a lot of energy, and also to produce antiprotons, we need to invest a lot. So it's very difficult to produce an engine, based on antimatter. Of course, that would be the ideal fuel, because if you have a fuel made of antimatter and matter and you mix them, you put them in two chambers, put them together, you get 100% of the rest mass converted into energy, and that would be fantastic. But we don't have any clue how to produce such an engine. It's possible that you have engines like that produced by more advanced civilizations. In the case of Oumuamua, one thing is clear: there were no gamma rays detected from it. There was a paper about it. So usually when you annihilate, you produce also gamma rays, very energetic radiation, and we haven't seen any. And there was no need really for an engine. What we noticed for Oumuamua is that the excess push that it exhibited away from the sun could be just as a result of reflection of sunlight, because it declined inversely with distance squared in a smooth fashion. So I would say that in the case of Oumuamua, it's more likely to be like a plastic bag, a trash bag tumbling in the wind, something very thin that was pushed by sunlight.
Thank you.
Thank you, Jacob. Klaus, welcome. I hope I said your name properly. Forgive me. While he works on that, let's look at Max here. What is your take on the developments in us regarding the UAP? Since the Pentagon can't explain what it is, how can it defy the laws of physics and how move, and can't see any of the propulsion system? Wouldn't this be a clear sign of extraterrestrial visits?
Well, I would not say that we just don't have good enough evidence. The images are fuzzy, the motion is unclear. The point is, it's not defying the laws of physics. Some people say that, but just to give an example, we have artillery shells that are accelerating at 100,000 G right now with electronic equipment on them. So it's not as if something moving at many G, a very high acceleration, is a violation of the laws of physics. Not at all. I mean, if we do see something moving faster than light, that would be a violation of Einstein's special theory of relativity. We haven't seen anything moving faster than light. And I should say the evidence that it was distributed publicly is not good enough quality for us to say anything. And that's why the Galileo project is aiming to get high quality scientific data using telescope systems in a way that is fully controlled. The data will be public and the analysis will be transparent. So the goal of Galileo is to introduce scientific rigor into this subject that for 70 years was ridiculed by scientists, and at the same time, most recently, the Pentagon report was declared as a serious matter by politicians, military personnel, and national security advisors. So on the one side, you have a very conservative organization, the government, saying it's a serious matter. On the other hand, the scientists who are supposed to be open-minded, blue sky research, are ridiculing it. So we are trying to fix that inappropriate situation with the Galileo project.
Great. Okay, Douglas here. Do you think there is some mutual agreement among alien civilizations not to interact with very early single planet species, like we have with tribes in the Amazon?
Everything is possible. There is also a possibility that a very advanced civilization would prefer not to engage with us because it would lower their life quality. In that case, we can still find out about them because they would still need to throw trash into space. And just like, journalists that go through the trash cans of celebrities in Hollywood, we can find about their private lives by digging into their trash in space. But there are many possible situations, and the only way to find out is first to figure out whether we are the smartest kid on the block or there are others around, and second, of course, to figure out their intentions and their agenda. And of course, for now, with lack of data, we are reflecting on our ambitions, our experiences. So that's very limited.
Very good. Magnus, hello. Your microphone is also muted right now. I hope you have the controls to unmute yourself.
It seems to be a general problem, I would guess.
Yes. Oh, he's thumbs up. Did you want to go ahead and ask your question, Magnus?
No. I think there is a problem with the platform that doesn't enable.
Okay. I'll mention this to Caro and Matthias, and maybe they can address it from Linköping there. I do not have any controls here. But in the meantime, if you guys want to type your question into the chat, please feel free. We can read that. So going on to the theme of the last couple of questions, what's your, so as a professor and a scientist, what are your thoughts on some of the more like popular culture type things like Area 51 and, people taking photos of USOs from the road in the sky and things like that, like visitation in modern history?
Well, I think the reports are probably a mixed bag. Many of them have mundane explanations. It's quite possible that some of the objects identified were of military origin, but the citizens that reported them were just not aware of the context. And in order not to reveal the actual nature of these objects, the government kept it silent. And that's why it sounds as if there is conspiracy, but it's not really. I mean, it has to do with instruments on the cutting edge of technology that the government doesn't want the public or other nations to be aware specifically about their capabilities. So the point of the Galileo project that I'm leading is that it may well be, I mean, it's a fishing expedition. We are sending hooks and trying to find any fish. And it's possible that a lot of the objects that we will find have mundane explanations. And the point is that it's sufficient to have one that is of extraterrestrial technological origin for this to be extremely important and have a profound impact on human history. So we don't care about the fish that we can explain, such as birds, drones, human-made objects. There are people in Washington, D.C. that would very much like to know about human-made objects, and there are zoologists that would like to learn more about birds. But as far as we are concerned, we want to see something else, and we will develop the software that allows us to look for something else that is unusual. And so if I had to guess, I would say most of the events that were reported have some explanation, but what we are trying to find is this one fish or more that are of great interest because they're unusual.
Got it. Interesting. So Magnus typed his question. Does your book dive into the different types of markers to look for, such as biotech and info?
Well, I have 2 books actually over the past 7 months. One is Extraterrestrial, that was translated to 25 languages, was aimed at the general public. The second is a textbook of more than 1,000 pages with my former postdoc Manasvi Lingam, called Life in the Cosmos. And there you can find a comprehensive discussion on all aspects of the search for both microbial life, primitive life, and technological life, intelligent life. So yes, the answer is you can find everything we know as of now on this subject. It's an update to the book that was written in the 60s by Shklovsky and Sagan about intelligence in the cosmos.
Excellent. Excellent. And maybe, Avi, you can see the text here as well, correct?
You mean the chat?
Yes.
Yes.
Okay, great. Maybe before you wrap up for today, type the names of your books once more, just so that people can find them easily. This session is being recorded, so people will be able to watch it if they miss it right now. But
okay, so let me just get. I will, in fact, yeah.
Yeah. As you do that, and I think by your time slot, we've got time for maybe one more question here.
Sure. So this is one book, and of course it's translated also to Swedish, and you can find it locally. And the second book, one second. Here is the second book.
Excellent. Excellent. Thank you. Do you have time for one more question?
Sure.
Great. So, Alec, if Oumuamua was indeed alien, shouldn't it have interacted in some way with Earth? Send a probe or something?
Well, that's if it was active, and it's quite possible that it was defunct, sort of like finding a plastic bottle that is punctured on the beach. Most of the time you see rocks that are naturally produced. Every now and then you see a plastic bottle. It's not functional anymore. So it could be just space trash. And of course, alternatively, it could have been a passive probe that is collecting data and just tumbling around, and we don't know its intent. We don't know its nature exactly because we didn't collect enough data. And the whole point of the Galileo project and my future hope is that we will get a high resolution photograph of the next one that looks as unusual as it is. And they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I wouldn't need to write a book if we had a photograph.
Absolutely. Okay, Klaus finally made it in. When do you think Galileo will be launched?
Oh, it'll become operational. Well, we are already having extensive discussions on purchasing instruments, and we are starting to put them together. And as I said, there are 2 components. One on Earth, trying to look at unidentified aerial phenomena. And for that, we are building telescope systems that have optical telescopes, a few of them that look at the object from different directions, such that we can track the 3D motion of it and get a high resolution image of it, and also infrared sensors and radio sensors. And the data will go to cameras and eventually to computer systems that will analyze them with appropriate software. And then the second component is finding another object like Oumuamua in future data sets and sending a camera that will take a close-up photograph. And so we are already working on both, actually. And in the coming months, I hope we will make progress on the instrumentation and the software development. And so I hope that within a year, we'll start getting interesting data. That's my goal. And I'm funded right now at $2 million. The money came from donors I've never known before, and they came to the porch of my home to ask me questions about my book. What we need is really 20 million or so in order to have a comprehensive study of this question.
Okay, great. All right, Avi. Well, are we wrapping up now for your session?
Sure.
Or do you have a few more minutes? Your session was scheduled a few minutes less than the others. I wasn't sure because of that was your time constraints.
Oh, no, it's not my time. That's what I was told.
Okay. All right, great. So let's do another one then here. So Sarah, I don't have a question, but just wanted to tell you that I loved your book, Extraterrestrial. Read it when it came out. Thank you for the precious talk and your answers here. I must come check out Life in the Cosmos now.
My pleasure. Yeah, by the way, I should say I wrote the book primarily to the younger generation because my hope is that, in the future, the question that I pose, are we the smartest kid on the block, will be answered. And it really will have a huge impact on humanity because when my daughters were young, they thought that they are at the center of the universe, they're the smartest. And then I took them to the kindergarten and that changed their perspective. And in order for us to mature, we really need to find others. And that's my hope with the Galileo project. And also with younger people that will read the book and go into this field of research. My point is this will attract more people to science and will bring new funds to science. So it's a win-win proposition. And I actually demonstrated that over the past couple of months with the Galileo project. We got new funds that were not allocated to anything else before. And I got thousands of emails from enthusiastic people and that would like to contribute from their expertise to the project. So altogether, I'm very hopeful for the future, and that belongs to the young generation. That's why I wrote my book. And by the way, it's not all a pleasant experience. Some people criticize, have pushback to this kind of research. And I should say, I feel, early on in my life, I was in the military, and I remember I trained in the paratroopers, and I remember that there was a saying that sometimes a soldier needs to put his body on the barbed wire so that others can pass through. And that's the way I feel, to allow younger people to work on this subject in the future. We have to go through this phase where people push back on it, because any frontier, any exciting frontier goes through these pains of labor, so to speak, to bring it to fruition.
Very good. Very good. All right. Well, thank you so much. We appreciate you joining us today. Your talk was very good, and really thrilled to have this opportunity to talk with you live. So thank you so much, and look forward to hopefully a future collaboration with another Warp Summit in the future.
Thank you for hosting me. That was a pleasure.
Thank you so much, Avi. Goodbye.